Before you watch this video, make sure that you've actually looked over the review and tried to do the questions yourself. This review won't mean a whole lot if all you do is watch me perform the operations. I really want you to have practiced this first. So the best scenario is that you try it on your own first and then you come for the questions that you struggle with or that you didn't get the correct answer as you look at the key. Alright, so for the first 15 questions, we're just finding derivative. All of these pretty much have to do with chain rule. So when you have something like this where it's something raised to the 12th power, you do the power rule. So it's 12 times that inside function to the 11th power, but then you also have to multiply by the derivative of the inside. So if we were labeling this, this is the derivative of the outside, and this is the derivative of the inside. And then clean up anything you can. Remember, we would not do distributive property here. So it's 36 times 3x plus 4 to the 11th. Okay, you can't do distributive property if you have an exponent, so keep that in mind. Number 2, anytime you're asked to find the derivative of an e function, you need to remember the format for derivative of e, right? The derivative of an e function is always itself, okay, but then times the derivative of the inside being the exponent. So the derivative of the exponent would just be 12x to the 11th. So again, if we wanted to label this, this is the derivative of the outside, and this is the derivative of the inside. So normally speaking, it wouldn't be wrong to write it this way, but normally speaking, we usually see the e term listed as last. Make sure you understand that this part right here is actually an exponent of e. So it's actually e to that power, and make sure you're writing it as such. Okay, what about finding the derivative of general ln functions? Well, the derivative of the natural log of something is always 1 over that something. So 1 over what's in the parentheses. Not 1 over x, that's only when you're doing the natural log of x. So it's 1 over what's in the parentheses, but then times the derivative, is that 12? So I forgot to write the 12 here. Times the derivative of the inside, which would be 12x to the 11th. So in the end, we would combine these together, 12x to the 11th over x to the 12th plus 15. And that's as far as we can go. Okay, don't do anything weird like try to cancel x's. You can't do that because there's no x present in the 15 term. Number 4, f of x equals 2x to the 5th plus 11 to the 7th. So the derivative is going to be power rule first, right? So 7 times that thing to the 6th power, right? So that's like the derivative of the outside times the derivative of the inside, which is just 10x to the 4th. So then when you clean it up, you have 70x to the 4th times the parentheses thing. Okay, I kind of got away from doing it on the last two, but let's go ahead and label these. This would be the derivative of the outside, and this would be the derivative of the inside. So chain rule is for more complicated functions. Here, this would be the derivative of the outside, and this would be the derivative of the inside. Alright, what if we have y equals e to the 5x? Notice when I went to list derivative, I would just say y prime. Let me move that up, sorry about that. So the derivative of an e function is itself times the derivative of the inside, which is the exponent. So this is the derivative of the outside, and then times the derivative of the inside. So we would get 5 e to the 5x power. All right. right, number 6. F of x equals 4e to the negative 11x power. Now, we don't need product rule on a problem like this. Remember, product rule is only necessary when you have two functions being multiplied by each other. This is just a constant of a 4 being multiplied by this function, so we're going to pull the constant down. The derivative of e is itself, and then times the derivative of the inside, which is the exponent in this case. So this is the derivative of the outside. This is the derivative of the inside. And so we end up getting negative 44e to the negative 11x power. Okay. Once you understand chain rule, you'll find it's not one of the most difficult rules that we do. It's just that until you understand that you're doing the derivative of the outside times the inside, it can be a little challenging. All right, so let's look at number 7. F of x equals 6 times the square root of 3x squared plus 9. So just like we did for test 1, we don't want to see things under a root or in a fraction when they could be written in another way. So I'm going to rewrite this as 6 times that 3x squared plus 9 to the 1/2 power, and then I can do power rule just like normal. So if I bring that power out to the front, I'll get 3 and then 3x squared plus 9. If you subtract 1 from the exponent, you get negative 1/2, but then you still have to multiply by the derivative of the inside. Okay, so this is derivative of the outside. Notice all I did here was product rule, not product rule, sorry, power rule, and then here is the derivative of the inside. And then if I want to clean that up, then you would do 3 times 6x, which is 18x. And then you would move this piece to the bottom since it's a negative exponent. So either form is okay with me as long as you rewrite the negative exponent. But remember, 1/2 power really just means square root. Okay, so I think the answer on the key actually looks like this, but I would have taken this. That would have been fine. Let me move that up. Sorry about that. All right, number 8. So we have f of x equal to x to the 5th plus 11 to the negative 6th. So who cares that that's a negative exponent? We're still going to move it around to the front. We're going to keep the inside the same, and we're going to reduce the exponent by 1, subtract 1 from the exponent. And then we still need to multiply by the derivative of the inside. So the derivative of x to the 5th plus 11 is 5x to the 4th. So this is the derivative of the outside. And this is the derivative of the inside. So if you rewrite this, it'll look like negative 30 x to the 4th, right? Because negative 6 times 5 is negative 30. And then on the bottom, and it's on the bottom because of the negative exponent, you'll get this. So that would be how I'd want your final answer to look there. Number 9, f of x equals 14 minus 5 natural log of x. So if I do the derivative of 14 is 0. The constant comes down, the derivative of ln of x is 1 over x. Okay, notice I don't have to do chain rule here because it's just the plain old natural log of x. If it were natural log of something else, we would need to do times the derivative. So this one actually does not involve chain rule. It's one of the few on this review that doesn't involve chain rule, but that's what you end up getting. Number 10. If f of x is 7 and then the natural log of 10 plus 3x squared. So the derivative is going to be, move the 7 down. The derivative of any natural log function is 1 over that function times the derivative of the inside, which would be 6x. Okay, so this is the derivative of the outside. In other words, I took care of the fact that it was an ln function here, and then I also multiplied by the derivative of the inside here. So in the end, 6 times 7 is 42, so you should get 42x, and then this 10 plus 3x squared would stay on bottom. Okay. Notice no cancellations can be made, because if you were going to cancel something, it would need to be present in all three, and these three terms don't have any common things to cancel. Number 11, f of x equals 17 plus the natural log of x, and then raised to the 11th power. So on the one hand, we have a power function, right? So we're going to treat it like a power function. Power around to the front, reduce the power by 1. Okay, so the derivative of the outside is just straight up power function, or power rule, I mean. But then we still need to multiply. That should be a multiplication sign. Multiply by the derivative of the inside. So the derivative of the inside would just be 1 over x. Think about that, right? The derivative of 17 is 0. The derivative of ln of x is 1 over x. So this part is the derivative of the inside. So in the end, the 11 and the parentheses thing stay where they are because they're not negative exponents or anything like that, and then the x goes on the bottom. Okay. I am writing these answers in the most simplified form, so make sure that you're not trying to make simplifications that are incorrect. Number 12, f of t equals 2 times t squared plus 11t to the negative 7 power. So if I want to find the derivative, power rule first, power out to the front, right, and reduce the power by 1. That's just half of the answer. That's just the derivative of the outside, and then I still need to do the derivative of the inside. This time, make sure if you have a two-part derivative that you put it in parentheses. It's actually incorrect if you don't do that. So this is the derivative of the outside, and this is the derivative of the inside. So if we wanted to, we could leave it as negative 14 2t plus 11, and then move this to the bottom. If you wanted to, technically, you could do distributive property on the top. It's not necessary, but you could do it because we don't have an exponent there. Okay, but I'm just going to leave it like that. So 13, square root of x squared plus 7. Okay, we had a square root one before, and remember what we did. Before we did the derivative, we immediately rewrote it as whatever that parentheses is to the 1/2 power, because then we can just do power rule. So bring the 1/2 to the front, subtract 1 from the exponent, and then also multiply by the derivative of the inside. So this is the derivative of the outside, and this is the derivative of the inside. So if you work this out, notice the 2 times 1/2 will go away, and you'll get x over either x squared plus 7 parentheses to the 1/2 power, or you can write it as x over the square root of x squared plus 7. Okay, but I would be okay with either form. As long as you don't leave the negative exponent, I'm not going to count off points. So 2 more where we're just finding derivative, and then we'll do some other applications of that maybe. So how do you determine when it's 2 different functions? The answer is if you can find an x in both parts, then each part is its own function. So in other words, this is a function, 11x, and the e part is a function. So notice, even though we don't say it, we are multiplying 2 functions together. It's kind of like we're doing 11x times e to the 3x power. Okay. So in other words, we need to use product rule here. So sometimes they'll have the multiplication dot and sometimes they won't. You'll just have to identify, hey, do I have two things with x in them? If so, then those are two separate functions. So remember, product rule is first, okay, times derivative of the second, but the second is going to be a chain rule. So notice I did the derivative of e as itself times the derivative of the exponent. Okay, so this is first times derivative of the second, and then plus the second times the derivative of the first. Okay, so I would probably be okay with it pretty much being left like this, but for the most part, you need to maybe try to look to see if they have anything in common. So I'm going to give you two forms of the answer that I would take. So you could either say 33x e to the 3x plus 11 e to the 3x, okay? Or if you show features on MyMathLab, they're always going to try to factor out like terms. Notice if you look at both groups, they both have an 11 in common and an e in common. So if you factor that out, you're going to get 3x, right? If you divide an 11 e to the 3x out of the first group, you get 3x. If you divide this by itself, you just get 1. Okay, so this is the one, the second one's the one I think that I put on the key, but honestly, I would probably take either one. But for later questions on the review, you're going to have to know how to factor, so it's good to practice that anyway, even though I don't actually require it on this one. So lastly, out of this group, g of x equals the natural log of 8 plus x divided by x to the 11th power. So notice I have to use quotient rule here. So if I want the derivative, it's going to be bottom times derivative of the top, so that's where you need to be careful. The derivative of the top is 1 over whatever you're taking the natural log of, but then times the derivative of that parentheses, which in this case is just 1. And then minus the second, or the top, sorry, times the derivative of the bottom, and then all of that over the bottom squared. Notice if you square x to the 11th, you get x to the 22nd. So there's a couple of things here. This is a pretty ugly looking problem, right? So I'm going to show you how you would need to kind of simplify this. So first, let's just simplify each part. You get x to the 11th over 8 plus x minus, sorry, I just lost my train of thought, the natural log of 8 plus x, and then times 11 x to the 10th over x to the 22nd. So all I really did was combine these first two. But then normally speaking, we don't leave a fraction within a fraction. So what we'd really like, this is understood to be over 1. What we would really like is to be able to combine these together, and we can't do that unless we have a common denominator. So we're going to multiply by what it would take to get us a common denominator. So we're going to get x to the 11th minus 11x to the 10th times 8 plus x, and then times the natural log of 8 plus x. All I really did is kind of reorder things, and that's over 8 plus x over x to the 22nd. Okay, so honestly, all I really did is combine these two fractions together since now they have common denominators. I did shift things around, right? I wrote this first, then this, then the natural log, but that's essentially all I really did. Okay, so now let's see if we can try to figure out something that these have in common. So let's just play with the top. Notice they have an x to the 10th in common. So if you factor out an x to the 10th, you're going to get x minus 11 times 8 plus x, and then the natural log of 8 plus x. And then I'm going to combine these denominators together. In other words, these are both in the denominator, so I'm allowed to combine them as such. So lastly, I know this is kind of an ugly one. To be honest, I probably wouldn't be this mean to you on the test. Okay, the review is almost always more difficult than the test will be. So in the end, I canceled out x to the 10th, okay, and I only have 12 left on the bottom. So at the end, you have x minus 11, 8 plus x. You could do distributive property there or not. I'm going to not. Okay, that's a plus. I don't know why I wrote it so weird. And then it's over x to the 12th times 8 plus x. Okay. We definitely can't cancel the 8 plus x's because every term would have to have an 8 plus x. So that one was kind of unnecessarily algebraically ugly. So I wouldn't necessarily plan on one quite that difficult, but definitely make sure you know how to do quotient rule mixed with chain rule. Okay, number 16, it says find the derivative and find the equation of the line tangent. Okay, so anytime you do that, you just need to find the derivative, and then from that you can find the slope. So here is my original function. Here is my x value. So first I need to find the derivative, which is move the power to the front, keep the inside the same, subtract 1 from the exponent, but then also multiply by the derivative of the inside. Okay, so this is another chain rule. It's derivative of the outside. On your test, you don't have to label what I'm doing here. I'm just doing that really for your benefit. Times the derivative of the inside. So if you clean that up, you're going to get a half of 4 is 2. So you're going to get 2 over the square root of 4x minus 11, because 4x minus 11 to the 1/2 power is just the same as square root. And then now if we want the slope, we just need to find f prime of 5, right? 5 is the number they told us to use. So 2 over the square root of 4 times 5 minus 11. So 2 over the square root of 9, or 2 over 3. Okay, so the slope is 2 over 3, and now I just need to use y minus y1 equals m times x minus x1. So y minus, okay, notice I don't have the y value, right? So maybe off to the side I need to find y. I can always find a y if I have an x, okay, and I can do that by plugging the x that I have into the original. So if you plug 4 times 5 minus 11 to the 1/2 power, that's 20 minus 11, which is 9, to the 1/2 power, which means take the square root. So it ends up being 3. So y is 3 when x is 5. So y minus 3 equals 2/3 times x minus 5. And then you can distributive property and use your calculator if needed, but you should get 2/3 x minus 1/3 when you're done. Okay, same thing for 17 and 18. Notice these are the same types of problems as you've already done before back in Unit 1. It's just that the derivative is a little more challenging to find. But once you find the derivative, the process is the same. We find the slope. We use the y minus y1 formula. Okay, so notice this one's going to require product rule. So first, times derivative of the second. So be careful about this. This is a chain rule, right? I move the power to the front, reduce the power by 1, but then I also have to multiply by the derivative of the inside of that. So that portion is pretty lengthy, right? It's first times derivative of the second plus the second times the derivative of the first. So you will need to clean this up. Okay, so we're going to do -1 times 2 times x cubed. So we get negative 2x cubed times 4 minus x. Here we have 3x squared times 4 minus x squared. So honestly, you can leave it like this since all we're really trying to do is slope, but I'm going to go ahead and clean it up like my math lab would. They would say, okay, this has an x squared in common and 1 4 minus x in common. So if you were to divide that out, you would end up with, if you divided this from this, you would have negative 2x. If you divided this out of this, you would have a 3 parentheses 4 minus x. But then inside that parentheses can be cleaned up. So this will be 4 minus x. This will be 12 minus 3x. So this would be negative 5x plus 12. So this is the fully reduced version, but I'm just going to say this. This is okay. If you leave it like that, I'm okay with that. Okay, I'm just trying to show you how my math lab would probably factor it and how you can make it simpler / factored out. But in the end, all we really want is the slope anyway. So we're going to find f prime of 1, because notice that's the value they gave us, right? So I'm going to use my factored / reduced version, but honestly, if you didn't reduce it, you should get the same slope. Okay, so it's just a more simplified expression, the one that I have. So I get a slope of 21. Okay, now I need to find y. So f of 1 is going to be 1 cubed times 4 minus 1 parentheses squared. So that's going to be 1 times 9, or 9. So now y minus the y value equals the slope times x minus the given x value. And that will get you what's on the key, which is 21x minus 12. Okay. Admittedly, the derivative is the tough part right there, right? So we had to do product rule mixed with chain rule in order just to find the derivative. But then everything after that is just what we've done before. All right, number 18, same thing, right? So f of x equals x over 4x minus 11 cubed. And we're told that x is 3. So quotient rule, have to do it, right? It's written as a quotient, so I have to do quotient rule. So quotient rule is bottom times derivative of the top minus the top times the derivative of the bottom. Here's where that's tricky, right? So notice for the derivative of the bottom, I move the power around to the front. I reduced the power by 1, and I also multiplied by the derivative of the inside. And then all of that is over the bottom squared. So if it's already cubed, when we square it, it's to the 6th power. So this one's going to clean up quite a bit. So we're going to get 4x minus 11 cubed, right? Minus, if you combine x times 3 times 4, you get 12x times 4x minus 11 squared. Now what I hope you can notice is that there's a 4x minus 11 squared at least in everything. So this is going to be able to cancel. It's going to leave 1 here, and it's going to leave 4 here. Okay, so in other words, this is just actually 4x minus 11 minus 12x over now 4x minus 11 to the 4th power. And then we can simplify, and we'll just have negative 8x minus 11 over 4x minus 11 to the 4th. Okay, I need you to be able to process that. Notice that we just got rid of what they had in common, and we could only do that if it was present in everything, right? But a 4x minus 11 squared was present in everything. But then in the end, we're really just needing to find the slope, right? So we're going to do f prime of 3. So negative 8 times 3 minus 11 over parentheses 4 times 3 minus 11 to the 4th power. Okay, use your calculator for that. But if you do use your calculator, you'll get negative 35. Okay, let's find the y, right? We find the y by plugging in the x we were given to the original. So that would be 3 over parentheses 4 times 3 minus 11 cubed. That comes out pleasantly though. You just get 3 over 1 or 3. So again, y minus the y value equals m times x minus the x value. And you will get what's on the key, which is, if you do distributive property, negative 35x plus 108. Notice for 16 through 18, you find the derivative, right? Simplify it as much as possible. Use that to find the slope. Then use your y minus y1 formula. All right, number 19, we did a problem kind of like this in class, but this is different because the drug is different. Okay, I think we did alcohol like whiskey or something, but the process is really going to be the same. This is actually easier than the one we did in class, really. All right, so notice this is, you always want, remember when you read a word problem, this is the concentration of the drug. And T is the time in hours since the injection or since they got the drug. So in part A, it says what is the rate of change? So notice when you see the term rate of change, you immediately need to think, hey, I need to find derivative. So I need to find C prime of T. This is not a power rule, or sorry, a product rule question, because this is just a constant. So the derivative of a constant times something is you just pull the constant down. The derivative of E is itself times the derivative of the exponent. So you actually end up getting negative 4.75 e to the negative t for the rate of change. And notice now we just need to plug in 1 and talk about what that means and plug in 4, okay, to the derivative. So if you plug in 1, you're going to get negative 4.75 times e to the negative 1. Okay, use your calculator. I don't expect you to do that without one. So you end up getting negative 1.75. Okay. Notice if we had a measurement, we would put that here, but we don't really have that in this problem. I kind of tried to keep it short. And then this one, we end up getting a negative 0.09. Notice both of these are negative, which indicates that we are, we have a negative rate of change, means that we're decreasing, right? The values are going down. Okay, so in other words, the concentration of that drug in the bloodstream is reducing. Okay, for B, I'm just going to say refer to the key. Okay, all I asked you to do was graph the original function, so you could use your calculator, but E functions all have, or power functions all have a certain kind of look to them. Okay, so your key is a lot better form of the graph than I would probably sketch for you here. All right, so I'm going to do the rest of the review in a part 2 to the review. Okay, so that we can kind of split it up and so that you're not watching it all at one time, hopefully.